Welcome to my YouTube channel Physicscafe by Manjeet Kaur. In this video, we study about class 9th physics chapter sound. In previous video, we studied about wave and its types. Sound wave is one of them. The sound that we hear around us is the type of energy made by the vibrations. These vibrations travel through air or any other medium and can be heard when it reaches our ear. So basically, sound plays an important role in our daily life. You can hear many types of sound, which are female sound, male sound, or baby sound in our surroundings. Let us discuss the characteristics of sound wave in detail. These characteristics are wavelength, amplitude, frequency, time period, and velocity. First is wavelength, the distance between the center of two consecutive rarefactions or compression. That means the minimum distance in which a sound wave repeats itself is called wavelength. Here we have wave in which the distance between two crusts is its wavelength. Similarly, the distance between two troughs is its wavelength, and the distance between one complete wave is also its wavelength. Here we have two waves in this figure. First is longitudinal wave and second transverse wave. In longitudinal wave we have two regions, one is compression, another is rarefaction. In compression, in which particles are closely packed, and in rarefaction, here in which particles are far from each other. So the distance between two consecutive compression is its wavelength, and similarly the distance between two consecutive rarefaction is its wavelength. Similarly, for transverse wave, the distance between two crusts is its wavelength, and the distance between two troughs is its wavelength. Wavelength is represented by lambda, and its SI unit is meter. Next is amplitude. It is defined as the maximum displacement of the particles the sound wave disturbs as it passes through a medium. In simple words, it is the distance between the mean position and the extreme position. Here we have wave which moves from left to right. That is its mean position and that is its extreme position. So when a wave passes through a medium, the particles of the medium get displaced from their mean position, and maximum displacement of particles from its mean position is the amplitude of the wave. So this is the amplitude of the wave. Here we have wave which move from left to right. In this, that is its amplitude. Which is large. So sound it produces is loud because of more height of its amplitude. And in this we have also wave which is moved from left to right, but sound is feeble because of amplitude is small, because of low height. So maximum displacement of particle from mean position to its extreme position is the amplitude of the wave. Amplitude is represented with A and its SI unit is meter. Next is frequency. It refers to the number of sound waves a sound produces per second. In simple words, number of waves passing in 1 second. Here we have wave which move from left to right. So in 1 second, one complete wave is passing through it. Wave frequency is high or low. Here we have wave which move from left to right. So that is its wavelength and that is its amplitude. So in this frequency is high and here that is its wavelength and that is its amplitude. So in this frequency is low. The main difference in both diagram is that because in 1 second in this diagram more number of waves is passing and in 1 second less number of waves is passing. So here when the number of waves in passing 1 second is more is its high frequency, and when the number of waves passing in 1 second is low, then we have low frequency. The symbol of frequency is F or mu and its SI unit is Hertz. Time period. It is the time required to produce a single complete wave or cycle. Here we have diagram in which waves move from left to right. So let's say point T. So wave when it required to pass through that given point, so that is its time period. So basically time required by one wave to pass through any given point is its time period. Its symbol is T. Its SI unit is second. Next is velocity. It is the amount of distance in meters per second that a wave travels in 1 second. In simple words, distance covered by wave in 1 second. So velocity, which is equals to distance upon time. Here we have diagram that is its wavelength in complete wave cycle and that is its amplitude. So that is its velocity. So distance covered by the wave in 1 second is its wave velocity. So its symbol is V. SI unit is meter per second because distance is meter and time measured in second. So velocity is equals to meter per second and its formula is V, which is equals to frequency into wavelength, which we use in numericals. Now we have to derive wave velocity's formula. We know speed, which is equals to distance upon time. Wave velocity is distance covered by the wave in per second. So speed, we write it as distance multiplied by 1 upon time. In sound wave, distance is equals to wavelength, which is between two crests, and similarly which is between two troughs, and which is between a complete wave cycle. So that is its distance. And frequency is 1 upon time. Thus we put the value of distance and frequency in this formula. We get speed, which is equals to wavelength into frequency. So we write speed in V and wavelength with lambda and frequency with f. So we get this relation, which is V, which is equals to lambda into f, which is wavelength into frequency. Here we have some examples of sound wave. A light wave travels through a medium which has wavelength 600 nanometer. Determine its frequency. Given wavelength, which is equals to 600 nanometer. We know velocity of light, which is equals to 3 multiplied by 10 raised to power 8 meter per second. We know wave velocity's formula, which is equals to wavelength into frequency. So we represent wavelength with lambda and frequency with f. So from here we get the formula of frequency, which is equals to V upon lambda. So put the values of wavelength and velocity of light in this formula. So f is equals to 3 multiplied by 10 raised to power 8 upon 600 multiplied by 10 raised to power minus 19. So f is 5 multiplied by 10 raised to power 14 Hertz. Thus the frequency of light wave is 5 multiplied by 10 raised to power 14 Hertz. Next one is sound wave has the frequency of 220 Hz and the speed is 440 meter per second in a given medium. So given frequency, which we represent as f, is equals to 220 Hz, and speed of sound wave, which is v, is equals to 440 meter per second. We know the speed formula, which is equals to lambda into f, which is wavelength and frequency. So from here we get the value of lambda, which is wavelength, is equals to v upon f, which is velocity upon frequency. So put the values of frequency and speed of sound wave in wavelength formula, which is equals to 440 upon 220. So we get wavelength, which is 2 meter. Therefore, the wavelength of sound wave is 2 meter in that medium. Next is a person is listening to a tone of 500 Hz sitting at a distance of 450 meter from the source of the sound. What is the time interval between successive compression from the source? Given frequency f, which is equals to 500 Hz. We know time period, which is equals to 1 upon frequency. That means 1 upon f. So put the value of frequency in this formula. We get t is equals to 1 upon 500. So time interval between The successive compression from the source is 0.002 second. Thank you for watching my video. Like my video and subscribe my channel.